In this video, let us continue to solve problems based on trigonometric identities. And we've got a problem here which says if cos theta plus sin theta equals the square root of 2 cos theta, prove that cos theta minus sin theta equals root 2 sin theta. So that's what you have to prove. Cos theta plus sin theta, if it is equal to root 2 cos theta, then prove that cos theta minus sin theta equals root 2 sin theta. If it is plus here, it is root 2 cos theta. If it is negative here, it becomes root 2 sin theta. Is what they're trying to actually show it to you. That's the only difference. But how? You know, we need to prove that now. All right, so let's start off with this. Right, so we have cos theta plus sin theta equals root 2 cos theta. So what we have to do is, let us square both sides first. When you square both sides, what you get is, you get cos theta plus sin theta, that is the whole square, equals root 2 cos theta, the whole square, right? So when you square this, it is of the form a plus b the whole square, right? So a square plus b square plus 2ab. So that becomes cos square theta plus sin square theta plus 2 cos theta sin theta equals, here root 2 square is 2 and cos theta square is cos square theta, right? Do not get excited to write this as 1 just because you know that cos square theta plus sin square theta equals 1, because some places we don't actually have to do that. What we have to do here is just shift the 2 cos square theta, or just keep this 2 cos theta sin theta on the left hand side and shift these entire thing to the right hand side. One reason being, you've got a negative sin theta, so we need a negative sin theta somewhere, and this is the best way to do that. So you write now is 2 cos theta sin theta, keep it on the left hand side and push this to the right hand side. It becomes 2 cos square theta minus cos square theta minus sin square theta, right? The positive cos square theta and the positive sin square theta goes to the right hand side and it becomes negative. So now 2 cos square theta minus cos square theta is 1 cos square theta, which is just cos square theta, and minus sin square theta as it is. I'm just interchanging the right hand side and the left hand side, which can be done, which is not a problem. Write this as it is, 2 cos theta sin theta. So now what do we do? This is a square minus b square, right? A square minus b square is a plus b into a minus b. So cos square theta minus sin square theta is cos theta plus sin theta into cos theta minus sin theta, which is equal to 2 cos theta sin theta. So now what we have to do is keep cos theta minus sin theta on the left hand side, which is equal to 2 cos theta sin theta divided by cos theta plus sin theta, because cos theta plus sin theta is in multiplication with this. So when it goes to the right hand side, it goes in the form of a division. So that's what it is. So now they've already given very clearly, if cos theta plus sin theta is root 2 cos theta. So right, so what we have to do now is, now we've got the left hand side, see, cos theta minus sin theta. That's why we kept it in the left hand side. So now we have 2 cos theta sin theta divided by cos theta plus sin theta. I'm going to write it as root 2 cos theta. So what happens here? Cos theta gets cancelled. And further, so what I'm going to show is 2 can be written as root 2 times root 2. Right? This is quite important in this context. Now what we've got here is, we've got cos theta minus sin theta equal to 2 sin theta divided by root 2. We've got almost everything that we want for this. We got the cos theta, we got the sin theta, we've got the negative sign, we've got the sin theta here. We just need root 2 on top. So what do? You know that 2 can be written as root 2 into root 2. So cos theta minus sin theta equals, I'm writing 2 as root 2 times root 2 sin theta, and we've got divided by root 2. So this root 2 gets cancelled, and we are left to the right hand side. So cos theta minus sin theta equals root 2 sin theta, and here it is, RHS. So hence we proved that this is equal to this. Alright, so that's pretty much it. I'll just give you some important points which you may have to concentrate on while you solve these problems, these kind of problems. First of all, remember that whenever you see cos square theta plus sin square theta, you do not have to replace it by 1 just because there is an identity which is sin square theta plus cos square theta equals 1, right? So Not always. So here you see we are shifting it to the right hand side. The reason being we need a sine theta on the left hand side, which is a negative sine theta especially. So we've got that here. And another thing that I like to say is, why did I shift this particularly? Well, all those things are a little more steps that you understand with experience, but otherwise the simplest reason is, you see we need a cos theta minus sine theta on the left hand side, and when you see that, you just keep it there and you automatically know, well, this has to be here, this shouldn't be here. So push this to the right hand side and naturally you're going to get some steps from which you're going to figure out, oh, okay, fine, here I've got it. And finally, this is an important thing which will be applying a lot more here, writing 2 as a product of its squares. So square root 2 into square root 2, or there might be a 3 which you have to write it as square root of 3 into square root of 3 and all those things. So these are the little important points that you may want to remember, kind of note down to solve these kind of trigonometric problems. So that ends this video as well as this problem. I'll see you in the forthcoming videos with more problems based on trigonometric identities.